Math 3, logarithmic expressions. So these first 8, we're just rewriting them. And remember, the trick is to go from logs to exponents. So it's log base b of x equals y. And you make it the base of y equals x. Okay, so this is my base, 1/7 of x equals y. Okay. Number 2, base of 7 to the b equals 24. Y to the x equals 95. And 13 to the v equals u. Okay, so when we're doing exponential form, it's just the opposite. We go log, the base becomes the base of the log, the input or output becomes the input, input becomes output. So I'd have x, so log base x of y equals 19. Okay, then we'd have, that's our base, so log base 13/9 of a equals b. That was kind of a crazy one, wasn't it? And then base of r, so log base r of 129 equals 9. And finally, log base y of x equals z. Okay, so that's just a reminder there. Now what we're going to do is we're going to use those properties of logarithms to help us figure this out. Now remember those properties, we have the product rule, which says log base b of 2 or more numbers multiplied together, we can kind of distribute that log and we add in between. So the x and y get their separate logs and we add them. Okay, we also have the quotient rule. It's kind of the same idea, except this time when it's division going on, we then split up and they each get their own, but the difference from the multiplication is that we're using subtraction. And finally, the power rule is that anytime we have a power in that input area, you can actually take that power and multiply it by the whole log. So those are the 3 we're going to use. Then notice we're given some of these logs, so we don't want to use a calculator here. So in order to figure this out, we've got to split it up. So log base 5 of 44. Well, what is 44? Isn't that 4 times 11? So I have log base 5 of 4 times 11. Well, now using the product rule, I can split them up into their separate logs. So I get log base 5 of 4 plus log base 5 of 11. Now, do I know what log base 5 of 4 is? Yeah, it's approximately 0.9. And log base 5 of 11 is approximately 1.5. So add those together and we get 2.4 for the log of base 5 of 44. So that's kind of the idea here, is that we're just going through and figuring these things out. Okay, so on number 10 we've got log base 9 of 1 over 49. Well, I've got 7, 4, and 6. Okay, so 49, isn't that really 7 squared? So I have log base 9 of 1 over 7 squared. And didn't we learn with the exponentials that a negative exponential is a fraction? So now using the power rule, I can bring that negative down and get negative 2 times log base 9 of 7. Well, 7 is 0.9. So negative 2 times 0.9 is going to give me a negative 1.8. So negative 1.8. Okay? So that's kind of all we're doing here, is kind of trying to see how we can split them up. So it takes some thinking. But there we go. Okay, so 16, that should be a fairly easy one. Log base 5 of 4 squared, right? So we bring that 2 down and get 2 times log base 5 of 4. Well, log base 4 is 0.9. 2 times 0.9 is 1.8. Number 12, log base 3 of 110. So 110, that's like 11 times 10, isn't it? So I split that up and we get log base 3 of 11 plus log base 3 of 10. Log base 3 of 11 is 2.2, of 10 is 2.1. Add them together, we get 4.3 for our answer. Alright, so these last ones, same idea. They're trying to make it a little trickier though on us. So, notice we've got some division here. Well, 36, that's like 6 squared, right? So I have log base 5 of 6 squared over 11. Okay, so I can use now the, quotient rule to split them up like that, and then I can use the power rule. So we'd have log base 5 of 6 squared minus log base 5 of 11. Okay, then we take this 2 down in front, so 2 times log base 5 of 6 minus log base 5 of 11. Well, log base 5 of 6 is 1.1, so 2 times 1.1 minus 1.5. So I get 2.2 minus 1.5, which gives us, what is that, just 0.7? So 0.7 here. Okay, so we're just using those rules to help us expand it out in a way that we can then solve it. Okay, let's take a look at 14 now. So I've got 12, which we know what 12 is, right? So log base 7 of 12 minus log base 7 of 121. Now, 121, isn't that 11 squared? So let's erase that to be 11 squared. So then that 2 comes down in front, and we get log base 7 of 12 minus 2 times log base 7 of 11. Well, this is 1.3 minus 2 times 1.2. So we get 1.3 minus 2.4, and then we subtract that, 1.3 minus 2.4, and that's what, like negative 1.1? Okay, and if you really wanted to, you could get a calculator and figure out the, look at this and see what else. If that's true, you can kind of use that calculator to check it. But the idea is here to help us practice expanding these logs. Alright, 15. So we've got 288. Okay, and we've got 8, 6, and 11 basically. So log base 9 of 288. So let's just go 288 divided by 8. That gives me 36. So that's really 8 times 36, and we know 36 is 6 squared. Okay. Now, could I just go 6 times 6 instead? Yeah. If I did it that way, I'd have log base 9 of 8 times 6 times 6. I'd split them all up. Log base 9 of 8 plus log base 9 of 6 plus log base 9 of 6. Well, 8 is 0.9, 6 is 0.8, 6 is 0.8. See, if we did the squared, it would have just been 2 times log base 6, so we'd just double it anyway. So we get 1.6, and so 2.5. And there we have that one. Okay. So we're kind of getting some clues based on what the problem gives us, aren't we? So 16, we have 420. Hopefully you realize if I divide that by 10, that's 42, which 42 is 6 times 7. So really we have log base of 4 of 10 times 6 times 7. So product rule, we split them all up. Log base 4 of 10 plus log base 4 of 6 plus log base 4 of 7. Then we see what they each are. So we get 1.7 here, 1.3, and 1.4. So that'll be 2, 3, So 4.4. And there we go, guys. So using those product rules, using that, we get that information.